Mendel and his P's. We've been talking about monohybrid crosses, mono meaning one gene, and we had different alleles of that one gene, which we labeled as capital A for dominant and lowercase a for recessive. And we made the Punnett square with the 4 possible gametes that there were with those different alleles. So we had the homozygous dominant alleles, we had the heterozygous, and we had the homozygous recessive. That's a recessive. In a 3-to-1 ratio when we had heterozygous and heterozygous parents. Here we have the heterozygous by the heterozygous cross. We called that the F1 generation with Mendel's P's. There were 2 heterozygous parents, and it was 3-to-1 ratio in the phenotype, 3 dominant and 3 recessive phenotypes. Now we're going to refer to the dihybrid cross, or looking at 2 different genes. Here we're tracking 2 genes, and we'll label them as A dominant, A recessive, B dominant, and B recessive. And when you cross the purebred A's and the purebred B's, you end up with the heterozygous condition for both of the alleles. The F1 generation is heterozygous for the A gene and heterozygous for the B gene. And we're going to cross both heterozygous parents in the dihybrid cross. When we do this dihybrid cross heterozygous parents, first we have to determine the gametes. We look at the male and the female, both are heterozygous. And we think about the law of segregation, Mendel's law of segregation, which says that individual alleles separate during meiosis or gamete formation. So these individual alleles, the dominant A and the dominant recessive A, the dominant B and the recessive B, all those alleles are going to separate independently. Any of these alleles can be passed on to the offspring, which leads us to Mendel's second law. The inheritance of a particular allele for one trait does not affect the inheritance of an allele for another trait. So we're going to look at these different genes separately. They do not affect each other in a pure dihybrid cross. And this is known as the law of independent assortment. So here we have the dominant A allele and dominant A, and either the dominant B or the recessive B can associate with this dominant A allele. Similarly, the recessive A allele can have a dominant B, which would make little a, big B, and this recessive A can associate with a recessive B. So any of these combinations are possible due to independent assortment. In trying to determine proportions or probabilities, when we did the mono hybrid cross, one allele, we had 4 squares. In the dihybrid cross, we're going to have 4 squared or 16 squares. And the way that works, we have the dominant A with dominant B and recessive B. Then we have recessive A with dominant B and recessive B. Similarly, for the male parent, we have the dominant A again with dominant B and recessive B. Here we have recessive A with dominant B and recessive B. And that's an orderly way to set up your Punnett square. First put your dominant A's and then your recessive A's. Then put your dominant B, recessive B, dominant B, and recessive B. And remember, the A and the B represent different genes, different alleles for different genes. Okay, then we'll go ahead and fill in our Punnett square. Just like you do for the monohybrid cross. Here we have capital A, capital A, capital B, capital B. Here we have big A, big A, big B, and little b. Here we have large A, small a, large B, large B. Here we have large A, small a, large B, and small b. We'll continue on with the rest of the Punnett square. Small b, large A, small a, large B, small b, large A, small a, small a, small b, large A, small a, 2 large B's, large A, small a, large B, small b, recessive A, dominant B, recessive BA, dominant and recessive B. Here we have a heterozygous condition for A and B. Heterozygous for A, recessive for B, recessive for A, heterozygous for B, and here you have double recessive. Have a look at that. And I went ahead and made a key so we can count up the phenotypes. Dominant A and B is going to be red. So let's look at all of the dominant phenotypes in our Punnett square. Okay, this is going to be dominant A and dominant B. Here we have dominant A, dominant B, dominant A, dominant B, dominant A, dominant B. And in this row, dominant A, dominant B. Whoop, that's just going to be dominant A. So we'll erase that. Here, dominant A and dominant B. Here,